Welcome, Fabrice, in our Holland's meeting, the Dutch Windev Developers Group. It's a Dutch-speaking developers group, so we have also Belgium. People who speak Dutch are member of our group. We are very glad that you will be in this meeting and to tell us something about your knowledge. We are honored about that. I want to ask Art to introduce you.
Okay, thank you. Good evening, everybody. Welcome, Fabrice. We are very happy, of course, to have you as our guest speaker. And for those who do not know Fabrice yet, Fabrice is a former chairman of the French Windev user group, and of course a consultant for many projects in many different countries. He traveled all around Europe also, I just heard, and in the States, Louisiana, and currently lives in Guadeloupe, where he does his consultancy and programming, etc. On a warm island. So he's better off than us, I think, in the cold weather. I heard there was snow today somewhere. You can find all these videos, etc., on his own site, which is called easily is FabriceHarari.com if you want to, and you can download also source code, and you have to, of course, to sign on. That's for me. I will give the floor to Fabrice.
Well, hello everybody, and first I would like to apologize. I'm not able to do this presentation in Dutch. I speak a few words of German, but that's about it. After that, it's just French and English. So you will have to listen to me in English. Just to complete a little ad presentation, and just so you know why I'm able perhaps to give you this information. I started using Windev in version 1.5. So that's a long time ago. That's about 25 years ago of experience with these tools. I wrote with Alain Duglad the first book ever published on Windev. It was called The Guide du Développeur Windev. It was in 2000. I helped create the first association, Windev ASSO, that's the French association, and they decided that I should be the first president. I did not ask for that. They just decided that that's the way it had to be. I have a lot of information available as video course. At some point I was selling them, and then I decided that I would make them available for free on my YouTube channel. So there are probably 80 hours of video course available there on multiple questions. One of those points is the replication, and in particular an open source called WX Replication. It's something that I developed in 2014, so it has now 7 years and it's still working fine. There's also other open source. One is called WX-EDM. It's not really visible on that slide because of the graphic that is at the wrong place, my bad. WX-EDM is based on the replication, so it's a replicated electronic document management system. That's about it. So I'm going to talk about replication in general and a little bit about WX replication because Ad asked me to do a short session and it's just too complex to cover everything. If you want to know more, you can go directly on my YouTube channel. You go on YouTube and you look for Fabrice Harari, and you will find more than 8 hours of a course on just WX replication. And the beginning of that course will look a lot like that because I started with that as a basic for this specific session today. So let's start talking about replication. So replication in general, a little about the WX replication. The WX replication is an open source project. It is protected under the MIT license. For those of you who are not familiar with the license scheme from MIT, it's basically you can do whatever you want with it. You do not have to make your own project open source. You do not have to even say that it is based on WDG replication. You do not have to give any credit to anybody. I did not want to prevent anybody from using that project just because of ego or things like that. You want it, you use it any way you want. The more it's used, the better I feel. It has been downloaded about 1,000 times since 2014. So I know there's a lot of projects out there using it. I personally have used it in many projects for me and for my customers. So it is working. You can use it when you want. Also on top of the YouTube channel with the 8+ hour video, there are about 30 pages of information articles available on my website. It's completely free. And you can download the sources of the project from my website also. Now let's see, what is replication? Well, replication, basically, it's about data. When we're talking about replication, the only thing that interests really is the databases. So that's what happens when you have several databases and that they need to exchange data. That's basically it. If you are in this situation, you are doing replication, even if you don't know it. Basically, it's therefore copying data between several databases. The replication starts as simple as 2 databases and 1 connection between them, or it can be as complex as a scheme like this. That's an example of a local application working in client server with the server, each server doing replication to another server that is doing replication to another server on several levels. So it can be very simple, it can be very complex, but it's all under the umbrella of replication. Now, the question that is asked a lot of the time is, when do you need replication? When do you want replication? And when do you not want it? So you want replication in cases where you have, by example, either a bad or intermittent connection. That happens both if you are in a country where you have a bad Wi-Fi connection, or it can happen also when you have people moving around. Mobile application is a very good example of that, because at some point or other, when you're working on a mobile, you will lose the connection. So replication is for this kind of case. Also, it can be used when, for security reason, you do not let access to your database from outside. What was that? We have special effect now. Okay. If for security reason the database is not accessible, and that's often the case when you're using a hosted MySQL or PostgreSQL database you're renting that on an internet provider system. External access is not allowed, so you will need to use some kind of replication if you use that as a central point. So that's the case when you have mobile user or when you have multiple offices. You also have the case where you have a website that has been added to a Windev application. And clearly the website is hosted somewhere in the cloud. The local application is not. So you have 2 databases and you need to share data between them. So those are the basic cases. After that, we enter in the more exotic cases. Replication is extremely well adapted for a backup system, especially when your database, your system needs to run 24/7. You cannot stop the database to make a snapshot copy of it. So if you have a replicated database at that point, well, the second database that can be is not local, you can put it in the cloud anywhere, is going to be your backup, and it's going to be a quasi real-time backup because you can have your database replicating every minute. So basically, the most you can lose is 1 minute of work. So that's a very good backup system. Replication can also be used as a load balancing mean. If you start to have a lot of users, your server is going at some point to start to have problems because of the load. Now, if you have instead multiple servers that are replicated between them, you can have a part of user on each server working on the same data with just a little time between the server for the replication. But that is an easy way to have load balancing because you will have 500 users per server. And each time you need more user, you're going to add a server for the next 500 users and so on and so forth. So that's a very good, simple system for load balancing. Also, and not instead that can go with the previous one, it can be used as a fault management system. If you have multiple replicated servers and one server is down, you can have in your application either clients that are going in client server to the connection or via replication. You can have a mechanism in place. It's very easy to do. Let's say if I cannot connect to my regular server, then I'm going to connect to server number 2 in my list of servers, or number 3 or number 4. And you can have this server in the cloud in geographical locations that are completely different from one or the other. You can have one in Canada, one in France, one in Germany. This means that if you have part of the internet going down for whatever reason, our friend Putin could be one of them, but it can also be a catastrophe like a fire that cuts a big internet cable, like a DNS problem somewhere, like whatever, earthquake of whatever. You can still work because the other one are in different places and there's a good chance that one of them will still work. So that's a good system for that. It also can be used as a way to reduce cost. By an example of that is when you have your main database, the one that is used by the big organization is Oracle, but you don't want to put Oracle and for each individual group everywhere that is not directly connected because of the cost of the license. So in a case like that, you can put a Hyperfile, by example, or Postgres or whatever you like locally and replicate to the main database that is the very expensive one. So those are examples of cases where you will want the replication. I'm sure there are others, but those are the main ones. So basically, replication is several databases not connected all the time, and they exchange data when they can, when they want, or when they need to. That's the basic principle of the replication. Now, there are several types of replication, and you have to be clear on that because most people who don't think really about replication are always thinking about the full bidirectional replication to databases that are exactly the same, always communicating. That's just one case. There are many, many different cases that can be very useful for you, and they are completely different. So the monodirectional replication, that can be the backup, or that can be simply that you have clients that are entering data, and that data is going to a server, and there's nothing going down. Then you can have the partial bidirectional. It can be the previous case, like you have client entering data, but from time to time, they're receiving information that they need to enter data. That's classical when you don't want to have the whole data on your phone. I just want to have what is needed for the mobile application, and you're going to send only what is created there. After that, you have the full bidirectional, which is used for backups, for really a full replication between servers and things like that. It can also be used for client to server and server to client. You may want to have your whole data locally in some cases. It depends on what data you're managing. So that's the different types in terms of directionality. But then there is also different types in terms of topology. You have the single level, the star typed replication, where you have one central server and around that many different clients. So that's one level. Then you have the multi-level, the pyramid type replication, where you have what you had before, but you can have several like that, and all of them are replicating to another level, and all of them are replicating to another level. An example of that is a case where you have a small replication system locally in each region, geographical region, where you have a part of the company physically present, and then they all replicate to the national level, so that each country has all the information about what is happening in the country. And then you have the whole world level, where all the country where you have part of the company are replicating. And clearly, it's not always the case that you want to replicate the same thing at each level. You may want to replicate absolutely everything at the national level, but in the international, the world level, maybe you're just going to replicate the financial information and not the nitty-gritty information about who's doing what in a little city of this or that. So that's another potential difference. And then you have two specific cases that are used only in very, very specific problem solving. You have the mesh type replication. That is a replication that is fault tolerant, with each database linked to at least two other databases. That can go with what I was talking earlier, with the load balancing and with the possibility to have servers in different countries. You can put at the same time the mesh system in there. The idea is that if you lose the connection between two databases, you do not want to have anybody orphaned. So they have a second database or third database or a fourth database they can connect to and replicate with. So that's for security reasons. The last one is the ad hoc replication. It looks a lot like the mesh replication, but instead of having fixed database to connect to, it's basically when a database meets a database, they exchange data. And that's something that I studied for cases like countries in Africa where you had guys going on in everywhere in small villages to sell stuff, and they would record everything on their mobile. And then when they met somebody else from the organization, they would exchange data one with the other. And the first one of those who would go back to the central point would have the data of all the others with him for the central point. So that's a case where you don't have a lot of internet access anywhere, and you want to be able to get as much data as you can, as fast as you can. That's quite interesting to put in place, but it's something that can be necessary for some cases. Now let's see how replication works. So now we're not talking about the type of the different types of replication. We're talking about any replication that you use is going to work like this. It's going to work in cycles. Each cycle of replication is going to exchange data between two databases. The first part of the cycle is going to be an up cycle where the client is going to publish data. The client is going to identify what needs to be sent, so that's the new data. And by new, I mean new since the previous cycle of replication. Extract that and prepares it and send it to the server. Then the server receives that data, verifies that the data is correct for all intents and purposes, and imports the data. And very important, is going to send back an acknowledgement saying, okay, I received that data, in order for the client to know, okay, that data was received. Now it's up from that point that everything is going to be new for the next cycle. And you do that again and again, as long as there is data to be sent from the client to the server. That is half the cycle. The second half of the cycle is once the client has sent all of his new data to the server, it's now going to ask for data from the server. Now the server is going to identify what needs to be sent, and that's again what's new since the last cycle of replication. And that's, of course, that's new from all the other clients or from the server. Extract that, prepares it, send it back to the client. And when the client receives, it's going to verify imports data and send back acknowledgement. As you can see, it's the same thing in the other direction. And again, that is going to be repeated as long as there is data to be sent from the server to the client. Now, that whole thing is one replication cycle. And that cycle can be redone every minute, every hour, every day, once in a while, manually when you can and you have connection. It depends on your system. You're going to choose what is adapted to what situation. And it's not because you don't have to choose one type for the whole system. You can have several offices that are replicated every minute, and you have at the same time the mobile user who are replicating when they can. So that's extremely important because it introduces a number of questions and problems that needs to be addressed. So let's see the different parts of that. You need in the logic to identify what data should go where. Are you going to send the whole database to everybody? You can. It's absolutely technically possible. But of course, if you do that, there's a price to pay in the time of transfer because, well, a mobile user doesn't need the data from 500 users on his phone. So if you do that, you're not going to optimize the transfer. Also, if you send everything to everybody, you are greatly increasing the attack perimeter for hackers. It means that they just need to access one phone to have the whole database there. Now, of course, I know that all of you always encrypt every database. If you don't, please do. But even like that, you increase the risk if you do that. So it's a good idea to really think about, okay, who needs what? And is it at the database level or the user level? What does that mean? Well, let's talk about this mobile application again. If it's a phone that is my personal phone, I just need the data that I use. But if it's a phone that is on the wall in the office, and when somebody goes out, it takes one phone and has that phone for the day, then it's not my personal data, it's the mobile data for everybody who's mobile. And I need to log in on my phone in order to access what I am allowed to see. So it's really important to really think about who needs to go where. Now, what do we need? Next question is, what do we need to transfer since last cycle? Anything that was created, anything that was modified, and anything that was deleted. Now, that already has several problems because anything that was modified, are you going to send the whole record when one field was modified, or are you going to send only one field? So that's the record level or field level that you're going to have to decide for your application. Also, another problem is that if you delete things in a file, you don't have it anymore. So you don't know that it was deleted, and you don't know to say to somebody else, oh, this was deleted. So that's also something that has to be managed. So because of that, there's also lodging about extracting data. When do you extract data? Do you extract it only when you're replicating, or do you prepare it beforehand in a journal? For the deletion part, it is much easier to have a journal, because when you delete something, you write it in the journal and you can send information based on the journal. Of course, that means that you need to manage a journal on top of everything else. If you extract during replication, you can do that by not deleting really the record, but just checking them as deleted. They're deleted logically, but they're still in the database, which is in many cases more and more becoming a legal obligation anyway. Not delete anything that was ever in your database, so that there can be controls. So that may not be a bad way also to do that. So there are two ways of doing that. You extract during replication, or you prepare beforehand with a journal. In all cases, once you have extracted the data, the result is a packet of data or several packets of data that needs to be sent. And we arrive, therefore, to the data transport part of the system. Now, in a replication system, you can send these packets in a lot of different ways, depending on your use case. If you're on the same LAN, if your replication is just in one big company physically, you can just copy the packet in a directory somewhere on a server and have a server watching that directory and just looking if something new arrived to be processed. That's perfectly doable, no problem, works fine. You can do the same thing even if you are distant by using FTP to copy the packets on that shared directory. And again, you're just going to check if there's something new. And when the client is waiting for an answer, every minute it's going to check on that directory to see if there's something back for him based on the name of the files. So that is one possibility. Then you can connect to your server using a web service. It can be a REST web service. In that case, you're going to do HTTP request and on one side and a WP page or a web service on the other side. It's the same thing basically. It can be a web service SOAP if you like this kind of stuff. It can even be emails. If the only communication system that you have allowed is email, you can send email with packet attached. Of course, in that case, you will have to have a very good management of packets not arriving to the server because emails are not reliable. It can be a physical medium, and that I'm thinking about the ad hoc system that I was describing earlier, where you have people really meeting each other and exchanging data. So it can be as simple as a USB key that is sent then to the server and plugged in and used like a physical directory. Of course, in that case, the time needed to do a cycle is going to be much longer, and you may have several cycles started but not finished. So that's another management system. It can be sockets. As long as you can connect via internet to something, you can exchange data. Or you can also copy the packets on a cloud drive like Google Drive, and again, check on it if so. Those, I'm sure there are other systems. I did not write a smoke signal on that because I tested it and it's not reliable at all. So no smoke signal. But except for that, if you have a communication, you can do a replication. Now, the import data part of the cycle. The principle is the same whether you're on the server or the client. You're getting packet and you need to manage them. So to process the packet first, you have to physically manage them. And that may be that you're going to unzip them, unsplit them, check them, have a CRC check for them. So that's all at the packet level. Then once you check that the packet themselves are usable, you can process them, you have to look inside to know where they're coming from. And you always need to know where the data is coming from in a replicated system, because you need to manage pointers for each couple of database. So that it's very important that you always be able to identify the origin. Once you know that, you need to read the content, verify the validity of that content, and validity at several levels. By example, you will have to verify the analysis version, because it's a very bad thing that you try to replicate data between two databases that are not at the same level of analysis. Take the example of I added 3 fields in a file, and I added them on the client. So the user with the new version are going to enter data in those 3 fields, and that data is going to be sent to the server. The server is not up to date, or it is, but another client is not up to date. And at some point, you're going to try to write data in fields that do not exist locally. So either it's going to crash, which is not good, or you're going to lose the data if you accept this kind of error. And so somebody will have record without that once they update. So that's not a good way of managing. So you need to be sure that the analysis is the same on both sides. You can even use that to first forbid the replication. If a client is not up to date, you tell him your analysis version is not good, go back and update. Or you can use the whole system as the update system. Nothing prevents you from sending the update directly, or where the update is, the link to the update, whatever you want, through the replication system, and have the replication system initiate the replication on the client. It's absolutely possible to include your automatic update system in the replication. In that case, you just need to update your server, and as soon as somebody tries to replicate, they are going to be forced to update. Also, you need to always verify if you're not receiving data that was already sent and processed. Why? Well, if a client sends data to a server, the server is processing it and sending an acknowledgement. For the server, that block of data has been processed. But if the client did not receive the acknowledgement because, well, its connection was cut before, the client thinks it sent the data, but it doesn't know that it was processed. So it's going to resend it. So that is absolutely a normal case in replication. It is completely valid. You need to manage that. So that has to be part of the replication system, accepting that there will be communication flows and reflecting that in your code. Once all that is done, you can finally import the data, put it in the files. That's the easy part. Except that you need to manage duplicates. You need to manage technical and logical ones. What is a technical duplicate? It's a record that has the exact same unique identifier and that you're trying to add a second time. That is something that can happen if there was a problem in the pointer somewhere. The client thinks that data was not sent already, and it's not true. It can be also that your analysis is badly made for a replication system and that you have unique key that should not be there. And we're going to talk about that later. It's a very important point. So the technical is unique keys that are the same and when they shouldn't be. Now, Logical ones are what happens when you have two yellow color coming in. What do you do? So this is something that you have to manage. Either you ignore the problem, you replace a record by another, or you merge records. So there are three different strategies that you can use at that level, and we are going to go deeper into that after that. Now, once the data was imported, you need to acknowledge that it was important and that you don't want to redo that. So very important to send the, okay, that is good up to 12 points so that the pointer management is okay. Your pointer management can be per database if you're using a journal, or per file if you're not using a journal, but in both cases you need to have that absolutely perfectly done, otherwise you're going to have problems. Your system, whatever system of replication you use, all that is general, that's not specific to WX replication. But in all replication system where you have data going back and forth, you need to have fault tolerance built in your code. It's possible that somebody did not receive the data, or not the whole pack of data they were supposed to receive, or that the acknowledgement was not received. Those are absolutely valid cases that will happen at some point. So that has to be part of the code that manages all that. And the acknowledgement has nothing to do with having data to send back to a client. You are first processing all the data sent from the client to the server. You have an acknowledgement for that. And then you have return data from the server to the client, again with an acknowledgement in the other direction. So those are two different things. Of course, because you're sending back an acknowledgement, it's basically a packet with a specific information in it. So it's done the same way than packet transport. You're not going to have a second transport mechanism just for the acknowledgement. It's going to be in the same transport system that you're already using, whatever that is. Now, let's talk about the problems and their solutions. Whatever replication system you're using, you are going at some point to run into those problems, and you need to solve them, and you need to solve them from the beginning of the conception of your system. If you don't, you're going to get in trouble, and it's going to be difficult to find. The first problem that comes to mind is the duplicates. And here I have three different examples that show different cases. The yellow I already talked to you about. Imagine that you have a system where you have stock management, you're selling stuff. And these things that you're selling have colors. Now, logically, all the colors should be created perfectly before anybody receives any physical stock. So you just have to say, okay, I'm entering that into my local stock, and it's the right color and everything is good. We all know that in the real world, that's not always how it works. You have things arriving on the dock and it just doesn't exist in the system. And you have to create it on the fly to enter it in the stock. And in that case, what's going to happen is that, okay, that is a user saying, okay, that is yellow. Okay, so I don't have a yellow color, I'm going to create it. Now remember, we are on a replicated system, which means that the fact that this user created a record does not mean that everybody else suddenly has yellow. It means that at some point, when the replication system sends the data, this yellow will be propagated to anybody else who also is doing replication. So there is always a delay. And that delay means that at the same time, another part of the system also received the same stuff and had the exact same problem and created the same yellow color. And now you have two yellow. Each one is a record. Each one has a different unique identifier because it was created on different database, but they are logically the same. or are they? And that's where you have a problem. Because you could say, you know what, I'm going to put an automatic system in place that is going to check for logical duplicates. Each time I have something coming from a client, I'm going to check on the color for that record, if it already exists, and in that case, I'm going to do that. Yeah, but no, you cannot do that, because yeah, it could be the same yellow, but it could be a dark yellow and a light yellow. Each guy who created that had only one yellow, so they didn't say it's dark or it's light. But in one case, it's a dark one, and the other, it's so it's not possible to manage this kind of stuff automatically. The only thing that you can do is have a system that finds this kind of problem in real time during the replication, or after that, reviewing it, or only when somebody complained that they have two yellow in their color and they don't know what to do. But at some point, you will need to have somebody coming in and saying, okay, what is that? Are those two the same? If yes, I have to do something. If no, I have to rename them. That's the easy part. But if yes, they are the same, then I need to merge the record. And you need to have a mechanism that is capable of merging the record and everything that is linked to that, which means deleting one of the two and putting the identifier of the remaining one into all the linked record of the system and replicating that to everybody. Knowing that during that time, while you're doing that, somebody may be linking more stuff to the yellow that you deleted, which means that you cannot just do that. You also need to have a specific instruction going down with the replication saying, I merged this and that. So the merge can also be done locally for the new record before this. So it is a whole process that you have to put in place. So that was for yellow. Now imagine that you have John Smith. Is it the same John Smith? Is it a company that is called John Smith and have many different places of business, and you created two in the same cycle? So it's the same company. But are they considered the same company into your system? Or are there two different customers with two different addresses and two different delivery systems and two different ordering systems? Can be the same company, but two customers for you. So having two John Smiths may not be an error. It can be absolutely correct. What do you do in a case like that? Well, if you are in a system where you can have this kind of problem, then you need to never display just John Smith. You need to display John Smith, zip code, John Smith city, John Smith phone number, something that is going to give you a visual unique identifier for the customer, for the user of the system, not to use the wrong one. But you need to do something. You cannot just do John Smith and John Smith 2, because it is the name of the company and it's the same one, and they don't want to see John Smith 2 on their invoice. So you need to manage that in a different way. That's a problem that you could have also on a non-replicated system, but that is coming up very more often in a replicated one. And then you have the cases of the invoice number. Let's take the example of a supermarket. Each cashier system is a computer. They are all connecting to a central server based locally. That's great. Except that when the server is down or when the network is down, suddenly nobody can work. Nobody can bill to the customers. So what do? You put in place a replicated system there, because you want to harden your system, and even if the server is down, even if the local network is down, everybody can still pay. And that's basically the most important thing for your customer. The problem at that point is that each cashier can create invoices or tickets. There's the same problem. So what you need to do in a case like that is go back to the old system where each person doing invoices had his own invoice book with an invoice book number. And in that case, it's going to be a database number or a database ID. Now, in my system, what I did for that is I have an ID, which is a GUID for the database, and that's not something that you can put in an invoice because it's big like that and nobody can read it. But I also have a short ID, 3 letters, that gives me plenty of room to have as many as I need. And that can be given automatically to each database when it is enrolling. So in that case, the invoice number is going to be 3 letters plus the local invoice number, and you don't have any problem. So that problem is curiously the easiest to solve. So that was for duplicates. Now let's talk about integrity. We all have integrity constraint in our database, in our applications, and some of us are using transactions and rollbacks when there is a problem in the system. That is something that you cannot use in a replicated system. Why? Again, you don't know when you're coding your program, you have to think of the replication as a separate system that is going to take your data, send it to the server, and get information back. And depending on when you're doing the replication and how you're organized, that replication can happen at any point, including in the middle of recording a transaction. So in that case, you're going to send some of the modification to the server. And if you do a rollback locally after that, the rollback is at the system level. You will not have a list of all the changes done into the database, and you will not be able to send that to the server. So suddenly you will have different data on the server and the client. So that's not a good way to work for a replicated system. Instead, you should be fault tolerant. And I've been using that for years, and I've never found a case where it's not possible. Every place where you think you need a transaction, instead you code in a way that say, okay, if that process fails for whatever reason, the user unplugs the computer from the wall, whatever happens, I'm able to restart my process, redoing without duplicating anything, which means that I'm always verifying when I'm writing something, if it was already there, and if it was already there, I just replace it. So if you're working on any system where you have, by example, an invoicing system with the stock link and all this kind of thing, when you put the invoice into the stock, so you remove things from the stock, you're not going to do it twice, but you're going to verify that it has been done. And you can do that with just a checkbox in your invoice and a checkbox in your invoice lines. And once you have that, if that line has been sent to the stock correctly, you put the checkbox in the line. If not, you redo it by checking when it was interrupted. If it's already there, you have the ID of the line, so you can check, and you have no problem. So that's a different way of coding. It's a little more complex to code properly, but in a case like that, you don't have any problem because you will never do a duplicate. You will never have something that is interrupted and is not the same on 2 machines. So that's the way to go. So that's the integrity problem. Now, the next problem is the problem of stale data. I was talking about that earlier, saying that you don't know when the next replication is going to happen. And because of that, it means that somebody can be 3 days a week without doing a replication. And once they do the replication, they can send data that was 3 days a week old to the system, which means that, by example, they can override a modification that was done during this 3 days by somebody else with old data. let's take an example about phone number. It doesn't matter really what it is, but let's say that one client is entering the phone number of somebody and it's entering it wrong. But it's not doing the replication after that because, well, it's the end of the day, there's no connection, whatever reason, and it leaves for 3 days. When he comes back, plugs in the computer, this phone number goes up. Except that during that time, somebody else, somewhere else, needed a phone number, found it, and entered it correctly. Okay. When the new old data arrives, the good phone number is going to be overridden by the bad. There's nothing you can do about that. It's a replication system, which means that last in wins. You have to understand that last in wins always in the replicated system. So there are some replication system where instead of doing that, they are putting a timestamp on any information. And if the local timestamp is older than the one that is already there, the data is not imputed. That's not a good system because it's not because the data was entered before on this machine and on that one, then it's not good and the new one is better. You don't know that. It's just a choice. So the last in wins is the situation where there's the least amount of problem in my experience. You may disagree. There's no 100% rule in there, but you need to have a system where you can manage that. And one way of doing that is to have a history of all the changes on every record of the database. If you can tell the user, okay, this phone number was entered by that guy at that time, and then this one entered this one at that time, you can have very easily, okay, that's the right information, it's still there. Up, I put it instead of the wrong one. That's another advantage of using a journaling system for the replication, because the journal of the replication is at the same time a time log of all the changes in the database. So that's something that I have put in place in some application so that you always know who modified what, who created what at any given time. And that allows you to correct a problem quite easy. Now, second page of problem. I think I have 6 pages of problems, so you have a few things to hear. We already talked a little bit about that, about the selective data access per user. When you're working in client server, you're achieving that by using queries and filters to protect data. And that means that I'm not supposed to see all the information about the other guy that is over there, or I'm a sales rep and I'm allowed to see the data only for my sector and things, or only my customers, and so forth and so on. It seems that stealing data is something that is very much a hobby for any sales rep, because they want to be able to go to the concurrent guy and arrive with their whole customer file. So that's something that needs to be addressed. So in network mode, it's simple queries and filters to protect data. In replication, you can do the exact same thing, send the whole data to everybody and use the same queries and filter that you are already using in your existing application. That will work. Or you can replicate only the data needed per user. If the user is the DB database, or of course, if you have the same computer or phone used by several people, then you need a bigger data set. So you can replicate only part of the data, but you still need to use your existing queries and filters to protect the data, because you don't know if at some point you're not going to need to add more data to that database for whatever reason. So everything you do in client server, you continue to do, and you add filtering for the replication if you can. One thing that you need to think about, and that is not simple to manage, is what happens when the permission for accessing data are changing. Because let's take the sales rep again as an example. Suddenly, and that happens quite a lot in my experience, suddenly the sales rep that was managing Minnesota is given 2 more states because he's doing a very good job and they want him to manage this state and that state. If you just change the data access right and that change your queries and filters that you're using in client server, that will work only if the corresponding data was already there in the local database. If it was not and you were filtering only Minnesota data there, now you need to send all data where the pointers are way past to that database, or you need to remove everything from that database and restart the replication from scratch. Either you add a new mechanism or you spend the time to rebuild the database with the correct data set. Now, that's a problem that you wouldn't have in client server because all the data is always there. That's new and improved problems for you, thanks for the replication system. That's for the selective data, okay. Yeah, something that may be available in your application. It's the local backup and restore of DB. And local can be at the server level or it can be at the client level, it doesn't matter. You cannot do that in a replicated system. If you do that, if you restore a database in a replicated system, then the pointers are going to be wrong and the data is going to be stale. And when you start to try replicating that to other client or other server, you are going to introduce a number of problems that is really bad. Now, if your system is built correctly, the replication is going to be blocked because the pointers are wrong. The server is going to say, I already had that, but you cannot send bad data to the other if your replication system is wrong. But the problem is that you're not going to get all the data that you need to refresh your database because the server knows that he already sent you this. So it's going to start at the point and you're going to have big holes in your data. So local backup and restore of database should be forbidden. You should have a mechanism that check that as much as possible during the replication process and eventually block completely the database till somebody in admin understand what happened and change stuff and correct stuff. It seems that I'm telling you that replication systems are much more problem than the solutions. Well, they are, but they also give you functionality that you do not have otherwise. So it's always a question of is it worth it? Now, the next level, the next problem is going to decide how you do your application for the edits. For the edits, you can either work at the record level or the field level. Remember that in conflict resolution, we saw that the last in wins. If you work at the record level, it is very easy. As soon as you modify a record, you send the whole record, that's not a problem. But if somebody else during that time did a modification on the same record, then you're going to crash that. If you work at the field level, it's more complex to code, but you will have lost data only if 2 users modified the exact same field during the same replication cycle. And that is much more rare than the previous case. So you have to manage that when you're doing replication and you have to be aware of that. The next problem is when you want to replicate also external documents. Like word processing, Excel, images, and so on, PDF, whatever. you have two possibilities. Either you're already managing your external document in a blob field as a memory binary memo, sorry, losing my words. And in that case, it's not a problem because they're going to replicate with the record in which they are stored. So you're already done, everything is okay. Now, if you are managing that outside of the record, and I've seen many people doing that, just because the user wants to be able to just open Word and work on this document, and it doesn't want to have to go in my application to say, I want to work on that document. That's the excuse that I heard many times. If you're in that case, then you have a much harder work to do. First, because you always have only the local path for the file that is not accessible by anybody else. So you need to translate that path to somebody that is going to be usable by the others. You're going to add the outside document to the packet somewhere. You're going to manage the name conflicts, possibly with a separate directory per user for the sharing problem. And you have to also be able to detect changes in external documents so that you can, again, replicate them with their changes. And of course, the user is not going to tell you when you modify the Word document because so there is a lot to go against that solution. I told you before that I created an electronic document management system based on WX replication. And I'm using the first system where every document is in a blob. There's not one document on the hard drive anywhere, which means that when the user wants to edit one, they can see it inside the application. They can, in some cases, modify it inside the application when it's a text file or something where I have an editor that can work for that. And when they want it outside, there's a button for that. They manage it. I know that they are modifying it because they requested it outside the application, which means that I have a tracking system after that to see, oh, the file was changed. I'm going to put it back automatically inside my application as soon as it is unlocked and replicate it. So it is much easier to manage this way. But in both cases, either it's inside or outside the database, you're going to need to manage the conflicts in edit when you have two users working on the same document. So you need some kind of version management in there, knowing that this one was managed by this guy, this one was modified by that guy, something. And it's there's no easy solution for that. It's always a nightmare to manage that properly. You can also have a problem when you want to synchronize data with other application database. Example, Outlook, Thunderbird, accounting system. The reason for that, and accounting, it's something where you can have the problem when you have a bidirectional information to exchange. Of course, if you're just sending your invoices to the accounting system, there's no problem. But some cases that are quite frequent is when you want to integrate the emails that you are receiving inside your database, because you want to have the each project with all its information in there, including the emails. So you need to replicate the Outlook database, by example, with your own. Now, each of these external application has its own mechanism or not to do that. And the or not is the most frequent case. Each system is going to have its own database schema. It's completely different than yours. So there's no analysis comparison in that time. It's an whole other ball game. And some, and that's very funny, do not have reliable IDs. Outlook, not to name it, if you take an email and change its folder, you put it from one folder to the other in Outlook, that will change its unique ID. I don't know who designed a system like that, but Microsoft has 4 different Outlook or 5 different Outlook coming from different places. And in some cases, you will have that behavior, and that's something that you will have to manage. And of course, because they are not replicated systems, most of them do not keep track of what was edited or deleted since last time you're talking to them. So that's a replication problem that is quite complex, and the solution goes through 2 different things. One, you need translation tables where the outside ID of the program is going to be linked to your internal ID, so that you know the next time that you do something that this ID matches that, so it's already there. And the second thing is, because there's no way of internally tracking what was edited or deleted, you need to copy an archive or their files at each time you're doing a replication and keep it for the next time. And during your replication, you're going to compare the old one with the new one, record by record and field by field. Everything that is not there anymore was deleted. Everything that is different from last time, it was modified. And everything that is there that was not there before was added. By comparing like that, the whole file, you're going to be able to know what you need to add, modify, and delete inside your own database. That process is not fast. If you have a big Outlook database, that can run for hours just doing that. So it's a pain in the butt, but it is possible. If it sounds like live in case, it is. We had to do that at some point. That's absolutely not fun. Okay. Next problem is, I already talked a little bit about that, is the increase in attack perimeter for the hackers. In this day and age, we really all have to be completely clear that our database are targets. What we're doing for our customer is extremely important. We are managing their data, and it is absolutely necessary that we do all we can so that their data is safe. For that, the first thing to do, of course, is to encrypt the data, always, all the files, even the file that we think is not important, everything should be encrypted. That means that we have a problem if we want to open the database to external tools, ODBC or EDB, all this kind of stuff directly. So that's something that we should not do anymore at all. Instead, we should provide some kind of API that they can call from the outside, or some kind of, okay, you want to access that data, we're going to extract just that you can access via ODB or something like that. So we need to provide some kind of mechanisms if they need to do that with a limited scope. But we need to have everything encrypted all the time, because now we have some part of the database at least that are on a phone that can be stolen, that can on a mobile that goes from town to town with the sales guy, and the sales guy is living in his trunk while he's eating, and all these kind of beautiful things. Remember all the story that we've read in the news about the guy from the FBI that has a top secret document on his laptop, and the laptop is forgotten in the tube. Yeah, that's great. And you mean that the whole thing is not encrypted? No, oh, it was just the FBI, who cares? So that's the kind of thing that we don't want to be at the center of. Well, at least I know that I don't want to be the guy who did not encrypt the whole system. One way of dealing with that also to help, if it's on a mobile computer, by example, is to encrypt the whole hard drive with Hyperfile. And personally, I'm using VeraCrypt for that. I can have the whole hard drive encrypted, which means that it's time I stop the computer. It's a brick. They can install a computer, but they cannot access any data at all. So that's something that we can think of because we are increasing our attack parameter, maybe we need to increase what is required of the admin system for each computer that is going out there. So that's something to think about also now. Now, the next problems are not replication problem per se. There's something that you can have in your client server system. But in my experience, when you're putting in place a replicated system, things have a tendency to increase in volume. So you may have to manage different time zones with how you store date and times in your database being different than what you display. That there's a lot of little fun things to do here. Same thing for different currencies. And I'm not saying only different countries because, well, different countries can use the same currency. There are some countries in the world who do not have their own currency and use the US dollar, by example. And that's something that you need to manage. And different languages. Now, you're already probably managing that in your application. But now we're talking about content management. We are replicating the content, and that content may need to be translated before being sent or this and that. So there are a lot of different cases that can happen when you're working on a replicated system that may complicate your life. Okay, that's I had only 5 slides on the problem. That's good. I was able to shorten it. Now let's talk about what you have already available in the PCSoft system. Native in the PCSoft system, you have 4 different replication systems. The first one, the oldest one, is the logged replication between a Hyperfile Classic only without any transport. Basically, you need to activate the internal journalization of the files for each file that need to be replicated. So you will have .gnl, like journal files on top of the other ones. And that is going to be used to send the data from one database to the other. You will have to code the transport between the different databases. There's nothing in that system for that. Then you have the universal replication. I think it arrived 2 years later. Works with every type of database, HF Classic, client server, Oracle, etc. As long as you have a way to write in it in the PCSoft tool, you can do it. Again, there is no transport available. What you have are instruction to create replicas files that you can send on the other one, and this and that and the other. So that is the second one that arrived. Then a few years later, they added the replication of Hyperfile SQL servers. And that one is even simpler to use because it's just a few clicks at the level of each server to say, okay, you're going to replicate that database with this server, or the whole, all your database to this server, and that's it. So that's very easy to use. And the fourth one that I included that is a little different is the HF SQL clusters. They are replicating data between all the servers, but the reason for that is to load balancing between the clusters so you can access different servers at the same time. So it's a little more advanced, but it's basically also a replication. So that is what is available natively in the PCSoft system, where you don't need me or my WX replication system at all for that. Now, the pros and cons of what exists in the system. It's available. That's a huge pro. We have 4 different replications available. That's great. It is simple to implement. The server replication is extremely simple, but even the other ones, the journaling and the universal, is quite simple with the replica being created with a few instructions. So it's quite easy to put in place if you just read the help. And the proof that it's very simple is that there are only a few pages of help to read. If you look at the instruction, there's no 30+ pages of instruction on how to use this and that, or 8 hours of course, just a few pages. So it's clearly very simple. You have included in that the automatic ID management. You may need to do some changes in your application because, by example, for the server replication, you need automatic ID on 8 bytes because they're using the first 4 bytes for the server ID and then the last 4 bytes as the automatic ID created locally. There are some potential problems with that. One of them being that if you're doing some web dev and you have a lot of server, this will crash. I tested that just because all the code that is in the browser side of web dev is JavaScript, and JavaScript does not manage integer on 8 with the same maximum value than Windev. The maximum value is much shorter. If you have, I tested it with, of course, the server number that you enter yourself, 666. If there is going to be a problem, it's with that number. And it didn't fail. I was losing information on the browser side each time I was passing an ID. So that's something that is not in the documentation in the few pages of help. Also, in all those systems, if you want to do some filtering for selective syncing, you need one function that filter the record. It's quite easy to put in place. So all that is available and it's quite simple. Now, the problems with those systems and the reasons why I developed WDG Replication, here they are. There are only a few pages of help to read. I had that in the good part, but it's also very bad because everything I explained to you before that you need to know if you are coding a replication system, because otherwise you will have problem, they don't talk about. So if you don't already know the replication, you're going to get in trouble with their system. There's no question about that. Now, with my course, you can use their system. No problem, because I'm explaining to you all the things you need to do for any replication system. So that's not a problem. But they are not explaining to you how to use a replication system. They're just saying, you know what you're doing? Here are the instructions. That's all. Now, the second problem is much harder for me to accept. It's the fact that their systems are black boxes. You don't know what they're doing, and you don't know how they're doing. Except if they changed something and didn't tell me, which they're perfectly capable of. They're not telling you if they're doing a replication at the field level or the record level. They're not telling you if anything is secure. Is it encrypted? Do you need to encrypt the replica before you send it, or is it already there? They're not telling you anything. So it's, for something that manages data, it's something that I have problem with. I need to know what's going on and how it's managed in order to be able to assess if that works for me or not. Now, they do not at any level take into account any of the problem we saw earlier. Everything I told you about, they ignore completely, or we don't know what they're doing at least. So if you have duplicates to manage, does it work with them? If you have a technical duplicate, will that create a crash? You don't know. Any of the problem that we talked about, you don't know what is going to happen. So that means that if you're serious about using their system, you need to test all the problems that I talked about one after the other to see what is happening and how to manage it. Now, the next problem that is extremely bothersome for me is just look on all the forum, in the French forum or the English one, and look at the question on the replication system. And you will see again and again and again, people saying, I put this replication system or that one, it doesn't matter which one. It worked very well for 6 months, and then it crashed. And now I have 15 clients replicated with a server, and I don't know what to do. And there is no answer to that because nobody knows why it crashed. There's no, when it crashed, the error that is returned does not tell you why. Nobody can reproduce the problem, and nobody can repair it, including PCSoft. Even the people who paid for the tech support, the extra level tech support and all that, the only answer that anybody ever got is delete all your client database and redo the replication completely from scratch from the beginning, which is all good and fine if you have one client or two clients, but if you have 20 different parts of the country, that's going to be a big problem. Now, why is that happening? Why are these replication systems crashing at some point and you don't? It may be because of all the problems that I talked about before. It may be the first time that you have a duplicate. It may be the first time that you have you're resending the same data because you made a mistake in your code. It's perfectly possible. It may be that a packet arrived altered because there was a transmission problem and it's not managed. It's perfectly possible that it is one of these classical problems. It's also possible that it's a bug in their application system, but that we don't know. So let's say that it's outside the replication system. It's just one of those many problems that can occur. Well, we don't know which problem. We have no debug system available, no test, no log, no nothing. So for me, when I tested this system, I said, I cannot use that and tell my customer everything's going to be okay. And then suddenly everything crashes and I look like a full nut piece. So that was the main reason why I created WX Replication, which was not my first replication system. The first one I worked with was when I was in a startup in Louisiana for 6 years, and I created a replication system for the project we had at the time. It was before it was in Windev 5.5 and before the different replication system, the native one, were existing. Okay, other problem that you can have with the native replication system are the fact that the transport is not available for some of them. So you will have some coding to do anyway. You have to code the transport level. And there is absolutely nothing available to manage what will happen, which is duplicated data. So all the problem that you can have. Now let's talk very quickly about what I did and what I chose in WX Replication. And I'm really being very specific. It is what I have chosen for that system. And these choices have a reason. First, I wanted that system to work everywhere. So Android, iOS, any system where you have the W language working, I wanted the WX Replication to be able to work, which is not the case for all the systems that PCSoft is offering. Some are just between servers, some are this, some are that. So if you need a full system, you're going to need to mix and match and do some strange things, and you're not even sure that it's going to work everywhere in all cases. So I tried to use the KISS principle as much as I could. For those of you who are not familiar with this acronym, it's our friend American who invented that. It's called Keep It Simple, Stupid. So I tried to keep it simple as much as possible. And even like that, it became quite complex because of all the things I wanted to do. And because I wanted it to work everywhere, I made sure that I was using the lowest common denominator. So I'm using only instructions that work everywhere. As you may know, if you're working in Android or iOS, you have a number of functions that are still not available that are available in Windev. Same thing if you're on the web. Also, because of different environments, there are some things that are just not available. So WX Replication works everywhere. It works with all databases where you can do a HAD, hmodify, and hdelete. And you need to have that because that's what I'm using to write in the database. You have all the sources available, which means that whatever you do, you can debug, you can test, you can make your own implementation, you can change anything you want. There is no legal constraint at all. You really, if you use that system, you're on your own. You can really, now, if you want, I'm selling hours of consulting, so that's not a problem. But I think last time I checked, there was about 1,000 download of the replication project. I had only tens of them contacting me for one reason or another. All the other ones, I don't know if they used it. I don't know if they are using it every day. Never, just looking at it to learn things. I don't know, but you can do whatever you want. Instead of a few pages of documentation, you have more than 30 pages on my website and more than 8 hours of video course. In this documentation, there is one very, very, very important document. It's an how to insert WX replication in an existing application with existing data. You have step-by-step instruction telling you need to do this, then you need to do that, and it goes to, okay, you arrive at that level, do a backup of your main database, do a backup of this, then run that utility on your database, then do a second backup, do this, and every step of the way. And it's not a theoretical document. I created that document when I was importing the replication in an existing database. And I've used it since for each of my customers, because of course, all my customers were not starting from scratch. They had existing system that they wanted to modify with the replication. It is open source, so you do what you want. And the transport is included. And I have chosen for the transport to use HTTP request and an AWP page on a web dev server. The AWP page is a REST web service. It's very simple to use. It's basically a page that is called by HTTP request with a packet, and it receives the packet, look what's in it, call the appropriate function, and send an answer. That's all there is to the web service part. So it's very simple, works very well. And remember that because the connection is temporary, you're not connected all the time to the database. You can, even if you use the 10 connection server, the free one, you can have potentially several hundred of clients replicating with that, because, well, they're not going to connect at the same time. And more than that, if the server is not available, the replication is just going to wait and try again the next minute or next hour or whatever. So it's a solution that can be free at the server level if you want it to be free. Now the basics of the replication. It's written entirely in W language. In version 19, the original version, I think there's also a version on my server in 20. Now, at the time in 19, there was no encryption available in Android. So there's also an encryption system, RC4, available coded in W language, so that it would be protected. It is a replication that is star-shaped. So if you remember what I was talking about, you can have as many clients as you want with one server in the middle. Now, if you want to do a pyramidal level, you just need to configure a second replication between that server and another server on top and have several levels like that. It is not included in the utilities that you have. You will have to manage each level separately if you just do that in the WX replication, or you will have to code your own manager. It manages any database that used HAD H modify and H delete. It doesn't matter the type of access, if it's the specific driver or if it's ODB or ODBC, it's only that. Can you do H add, H modify, H delete? That's the criteria. All targets, if W language works somewhere, the replication, as far as I know, works too. Now, you may find a case where something is not working for whatever reason, but I haven't been able to test all the cases, but right now it's working everywhere I tested it. The transport is via HTTP request and encrypted. Not mandatory. You have the possibility to say, I don't want to encrypt for whatever reason. If you want to increase speed and you are inside an enclosed local, you can do that. It is working with automatic GUIDs. Now, nowadays, PCSoft has added to their database, to HFSQL, the possibility to use a GUID as automatic ID. But that's not what I'm talking about. First, because that may not be the case in all databases. That's in HF, so that's not something that I can take for granted everywhere. And also because in version 19, that did not exist. So the automatic GUID are managed automatically by the replication system. You just need to have the right field, which is a string, with the right name. That's all that's required. The replication does not support the automatic ID that you are used to with 1, 2, 3, 4, 5. That is not possible. And that's one part of the how-to document. It is telling you exactly how to replace your automatic ID by automatic GUID in your system, with a utility that will go through the whole database and modify the content the way you need. It works at the field level. If you remember the edit problem, record level or field level, that works at the field level. Also, that is done automatically, which means that each time you're doing H modify, the system will automatically detect which fields of the record were modified and will do what is needed for that. It is working in the last in wins configuration because, in my experience, that's the least painful one for the users. And one big constraint is that you can write in the database only with HAD, HModify, HDelete. You cannot use an update query, by example, or a delete query. Why? Well, there are replication systems that are working at the database level where you can do this kind of thing, no problem. And the PCSoft automatic one is, between server, by example, is one of those. The reason why they can do that is that when you're doing a query, update query in your system, they know exactly which record was modified. So they can replicate the modification at the record level or the field level. When I'm doing an update query in my code, I have no way of knowing all the records that were modified. I don't have an easy way to do that. Worse than that, because I'm doing that at one point in time and maybe not replicating immediately, it is perfectly possible that locally I had 5 records that match my condition in my update. So I updated 5 records. But that during that time, on another client, somebody created 3 more records that would also match that query. Which means that if I try to send just the query string and re-execute it on the server, I may modify 8 records instead of 5. And then I have different data in different places. So that's not something that I can do with a replication system that is at the application level and not at the database kernel level. Now, what is available in WX replication? You have one Windev program that is an example that is basically your project. Your project is going to be that program. You have one replication engine for the Windev program, and that's going to be a separate executable. Now, the reason why I chose that solution instead of putting the replication system in a secondary thread, is simple. I wanted to have that separate executable able to run 24/7 on the machine, hidden in the system, and just start the program, the Windev program, when needed. By doing that, the local database was always up to date from the server as soon as the main program stopped. So that was the reason why I chose that solution. If you have your whole replication system inside the main program and your main program does not run all the time, then when you start, you will have to wait for the whole data from the server to arrive before you are up to date. So that's always a choice to make. In the WDG replication system, there's also an Android program. Example again, that will be your project when you want. As on Android, it's not possible easily, at least, to have a second program working on the same database. Here, the replication system is included in the Android program and run on command. And there is one web dev project with 2 AWP pages for the server, for the replication server. One of them is the connection page for the web service, and the other is the back office system for the server, the maintenance page, if you want. There is one utility window in the Windev program that allows you to test your analysis and prepare your existing files. That's part of the how-to. They're going to tell you, run that window and press the button, and it will look in the analysis and tell you, okay, you need to modify this, to change that, this key has to be replaced by that, and all that, and more, with several steps also in the system. You have the step-by-step how-to that I talked to you about to integrate your project. You have utilities to manage the database enrollment. So for those of you who are not specialists of replication, the enrollment is what happens when you add a new database to the replication system. So each time you have a new client, a new PC or a new Android phone or a new whatever, or a new server that comes into your replication system, you need to enroll it. And that means that you need to know it's there, you need to accept that it's there, and you need to exchange data with it so that it is up to date. So that's the enrollment process, which is something that you need to do in any replication system. Here you have a system to manage that. There are many ways to do that. It can be completely automatic. Here, it is a manual process done by the administrator of the system, where basically you have a client, you install the program on it, it connects to the server for the first time, and say, hey, I'm new, I would like to replicate. And the server say, you're not enrolled yet, shut up. And it appears in the list of database are not enrolled, and the admin say, okay, I know who that is, I'm going to activate it. And then the next time the client is trying to replicate, he say, oh, I'm active, okay, I can do the replication. So that's the way I chose to do it, because it seemed to me that in our business, it was the most frequent case where you have an admin system in place for that. But it's absolutely possible to do different. You have built in the system a selective replication by file and direction. So you can say that this client is going to publish this and receive that. You can do that at every level. So that's already there. And you have a system that displays the replication history. So you know that this client replicated at that time, and you can see if somebody is not replicating or if there are problems. And there are a bunch of maintenance, test, and debug tools that I use personally to create the system and to test the system and to verify that everything was working. Like, by example, calculating a CRC on the files to verify that the files are exactly the same in two databases. So that's something that is available in all the systems. How does the replication itself work, now that you know a little of that? Well, what I did is I created a global procedure called hadd, hmodify, and hdelete, and they overwrite the regular one. So you don't have anything to change in your program at that level, simply because, well, hadd is going now to call the replication system. And the replication system is also, of course, going to the real hadd in the file, but is also going to add the information inside the replication file, which is a journal. Same thing for the hmodify and the hdelete. That information is already formatted, ready to travel. It's a text memo with everything written in it, and you can humanly read it and know what's going on. That is not the most efficient in terms of size and in terms of transport because of that. But when you want to be able to debug, that is extremely important to be able to read a replication record and say, okay, in that replication, there was a modification in that record from that file, and the new value is this, and you can see exactly what is going on. It is ready to travel, okay, and the engine, well, the thing that does the replication, whether it's the external engine or the internal built-in utility, works only on the replication file, which means that the pointers are only on one file instead of being on all the files. That's choices that I made. The system knows the date time of the last sync record in UTC mode, and that's the pointer that is used to manage the whole system. The system is going to create a packet, a blob of information with all the records of the replication that needs to be sent, including blobs, documents, PDF, whatever, encoded in base 64. All that is automatic. It's going to encode and encrypt the packet and send the packet. Now, other thing that you need to know, you can have only one unique key per record, and that's the GUID. You cannot have a unique key on a phone number, email, color, or whatever. You can use only keys with duplicates. And that is because we need to manage the case of multiple creation of the same information on multiple databases. So that's one of the changes that you may have to do in your application. Because of that, you may have to change some code in your application. If you were relying on a unique key on the address email in order not to create the second time the same email address, and you were just doing an hadd and saying, okay, if I have a duplicate error, I'm putting a message and asking to enter another information, you cannot do that anymore. Instead, you need to do a read seek of the email address, and if you find it, put your message. If you don't find it, do the hadd. So that will not prevent duplicates at the replication level, but that will replace your existing code. So your previous hard logic at that level has to become fuzzy, fault tolerant. Your application logic has to change because there will be duplicate. You will have two yellows, you will have two John Smiths, you will have all that, and you will need to manage that. I told you that the transport is HTTP, and the reason why I chose that is that it basically works everywhere. You have the port 80 and port 43 that are basically open on every system because they need to communicate. If that's not the case, that you will need another replication transport mechanism. That's up to you. Sorry. The enrollment of database is manual. I told you that it's made by an administrator in the back office system. There is a dump mode for existing data. So you can say that when you create your replication system originally, you already have your database that was the database of your client server system. And the first database that you link to your server is going to be the one where you have data. And you're going to say, instead of putting it in active mode when it wants to replicate, you're going to put it in dump mode. And in dump mode, the client is going to say, oh, okay, I'm going to go through all my files and add a record in the replication journal for each record in my file. And I'm going to send that to the server. And that is the mechanism to integrate your existing data, your client server data, inside the replication system. It's already built in. As for the replication itself, you have the choice. You can have it manually started by calling a function. It's basically calling start the replication cycle, and you're done. So you can do it whenever you want, when the customer clicks on the button, when you close the program, when you start it, whatever. Or it can be on a timer every n minutes or hours, whatever you need. Of course, it can be different on the phone than on the laptop of the sales rep and on the desktop of the user in the office. That's up to you. That's entirely open. Now, that's basically all I have to say on the existing system, the open source. Now, since I published the last replication open source, I've been working a lot for customers that wanted the system but needed more things that was available. So I added things that are not available in the open source. This is just to let you know a little bit about all the things that have been done in the last 7 years that can be done if you need them. I made a few small changes so that it would work in iOS, because there's this UTF-8 compared to Unicode difference in iOS. So it's not major, but it's a little thing to change. Made a lot of optimization of the system at the level of record size, also by the management of ANSI and Unicode, because originally it would manage only Unicode, and on the replication speed by modifying the queries and all that, and that data filtering. So that's a lot of different things that were done to improve the system. I created several enrollment systems depending on the case, the use case that we had. I added a group and entities level so that you can have somebody enroll in an entity which is part of a group and have only the data from that group entity flowing to it. So you can use the same server for several companies, by example. Also several organizations that have local antennas, and data is not going to flow to somebody who is not concerned directly at that level. I created an enrollment system that is completely self-service. So the user basically connect and say, oh, I'm new, I'm this guy, and you're done. There's nothing to do. And also created systems that were completely hard-coded, where there was no administration, but only a few people could connect. So that's different cases. I worked on the ad hoc replication system that we had talked about, with the people going from one place to the other and it changing between them. Unfortunately, that was a project that ran out of money, so I was not able to finish it. It was extremely interesting, but not finished. I curiously also worked on de-optimizing the system because the system as it is already optimized not to send data that doesn't need to be sent and not storing data that doesn't need to be stored. But I needed to store more data locally in order to be able to display this journal of all the changes, who changed what. That's not an information that was available outside of the server. So I had to de-optimize and send that information to everybody for a customer who wanted to have information available everywhere. And I worked also a lot on hardening the application by managing multiple replication servers at the same level. with automatic load balancing and automatic switching in case of problem. What that means is that I built a system, it was for first responders, that needed to be working all the time. Even if a server went down, they needed to be able to work. So I put in place multiple replication servers that are replicating between them. And if one of them goes down, the user who were connecting to that server knows the other one and are going to connect to the other ones. And you can add a server to that system, and the IP address of the new server is going down through the replication, which means that it's available for others. So at the same time, it would load balance because each group of server would work, of user would work on a different server. But in case of problem, it would switch automatically to another one. So that's a lot of things that I worked on since that time. And I'm sure that there are lots of other things that we'll work on because it's a system that always is available for any different cases. So that's about it. And now that I have your attention and something that is not about replication at all, is I'm looking for a job, either employee or consultant in Europe or anywhere with work visa. I'm ready to travel. I spent 15 years here. Now it seems that it's time for me to go somewhere else. So if any of you hear of something, please send the information my way and we'll talk. And that's it for me today. So I'm open for all questions on the replication system. Please feel free to go deep.
Thank you, Fabrice.
Thank you
Great
very much,
presentation.
Fabrice. Art, you go on.
No, well, actually, we can go on, of course, with the questions. Yeah, don't hesitate to ask Fabrice. He's here now. Who wants to start?
I have a question about the automatic GUID. Does this GUID replace the automatic ID, or is it side by side?
It replaces it. The system is in the how-to. It will tell you, okay, we detected that you have automatic ID, that name in this file, and so on and so forth. And it will tell you, okay, you need to create in those files a field called the ASGUID file name with the exact file name in it. By doing that, the system will know that now the automatic GUID field is available. And once you have done that and the system has checked that you didn't forget anything, it will automatically, you will run the utility that is there on the next step, and it will automatically read the ID, the main ID that you all currently have, create the corresponding GUID in that file, and then go through all the linked records everywhere to change, to add that GUID also in the secondary, as a secondary key in the other files. All that is done automatically. Once that step is done, it's going to tell you, okay, now that that is done, you need to delete all the automatic IDs from your file in the analysis. And that will be the next step. So all that is done. There's no risk of losing any information. You're just replacing the automatic ID with the link to the secondary ID in the other files by the GUID, step by step.
Why did you make it in version 19?
Because that was the last version available at the time. It was in 2014.
Oh.
So
okay.
Now I'm currently using it in version 26 because I didn't switch to 27 yet. There were a few changes in the code because of that, because since then, by example, the compiler has become more strict about the type of field that you send to function or methods. By example, in 19, you could send an ANSI string into a parameter that was described as Unicode string, and it would automatically change the type. And now, instead of automatically changing the type, it's creating an error in the compiler if it knows that it's an ANSI string. And if it doesn't know it at the time, it's going to crash at execution. So because of that, I had to modify the sum function or modify some code in my program when I went to 22, 23 and upper. But that's not a big deal. It's really a question of typing. And I found some solution to go around that quite easy.
Okay, are there other questions? Mark?
Yes, you've given me a lot of ideas because I'm also playing with the idea. I'm having several locations with their own local HFSQL, and I'm trying to make them go to a web server of mine with which I can produce statistics. I understand what you're doing, but my experience is that I'm trying to use more and more SQL statements for updates, because walking through the file, modifying something for several lines simply takes too long with these local systems, which are possibly using old computers and who are not the fastest. But it's for me, it's a small problem that I'm not allowed to use SQL statements, update statements.
Yeah, and that's because it's really at the application level and not database. In a case like yours, the only good way of doing the replication would be to have a replication between servers. For example, using the one that is available between HFSQL server from PCSoft. The problem is what happens when it stops working. And that's a question where I do not have an answer. I can only tell you, look in the forums about replication, the French forum in particular. You will see that people have had that problem with basically all the replication system that PCSoft is offering, and nobody knows why. So absolutely, my system has a constraint that is a problem for you. Now, I have to say, I don't know what you're doing in each of your location, but I have never seen a case where the work with HModify was too slow. I have seen cases where the logic of the application could be changed to improve the speed, but HAD or HModify, I'm doing hundreds of HAD by seconds. I have tested my system to see really what I was doing, and on a computer that was not specifically fast on the hard drive part and so on, I was, I think, at 320 record added in 1 second.
Yeah, well,
so
it's for restaurants, and those guys are really cheap.
Yeah, always.
So it's a simple question of moving everything was ordered on one table to another table. That might be 100 lines, and all you change is the table ID. So now I use an SQL statement, and it's immediately ready. The computer can go to the next table.
Or you could change only one record by changing the logic. If you add one level in your logic, you say, okay, I'm creating a logical table, and I'm saying that logical table is on the physical table 10. And now I'm changing it to 11. I change it once, and everything is linked not to 11, but to the logical level.
Of course, that's true, but there are a lot of complications.
Oh, yeah, I know. I'm just saying that I've never seen a case where you couldn't go around. So if you want to use a system, I think it's possible.
Yeah.
But there's always a price. So you have to choose which price you're ready to pay.
And another thing, would it be possible, for example, locally I have 50 fields in a record. Would it be possible to centralize only 20 fields?
Currently in the system, there is nothing that does that. Now, you want to add that, it's just a question at the replication level to add the information saying we want to manage only the fields that are either in that list or even you could add a prefix or a suffix to each field name so that automatically, if it's _RPR, I'm going to replicate it. So it's perfectly possible because remember that we are working on each record individually, and the system is automatically looping through all the fields of each record in order to manage them. So if at that level you just add your filter, you're done. So it's absolutely possible. And it's also possible to have a completely different database schema on the other side if you add that functionality. It's not available right now, but it is possible.
Yeah. And what I did not quite understand is how you manage several versions standing on all locations and having more fields, less fields working towards it. Yeah.
I forbid it currently in that system.
Okay.
I'm comparing the version analysis, and if it's not the same, I'm saying you cannot, because I don't want to lose data.
That's why I want to use less fields as possible, because I cannot force every restaurant to go to the same version. Some want to stay in version 16 and other ones are in 27.
Well, that's the thing. It's really a question of, I try to create a general case. If in your case you want to manage that way, you can just remove the test on the analysis and say, okay, I'm never going, if I add records, if I add fields to my record and they don't have them, no big deal. Now, what happens is that in that case, you need to always have the server at the last version with the maximum field and never delete fields at that level.
Yeah.
But in that case, okay, even if you send back records with information in those fields, they're going to be ignored because the fields are not there to be written in. So that's not a problem. It's a very simple modification to do, not something that I had in mind when I created that system, clearly. But there are so many different cases that, yeah, it's perfectly valid.
No, you've given me a lot of ideas, so thank you.
Is there another one who has a question?
Yes, I still have a question about the GWT. Will this affect the relations between the tables?
Well, that's part of the
referential structure.
Yeah, that's part of the changes that you have to do in your analysis, because currently you probably have links between files based on the automatic ID. Once you've finished implementing the how-to, you will have your link between GUID because the IDs are not existing. And that's one of the steps that you have in the how-to, exactly when first you add the empty GUID field, second, you populate them, third, you create the links between them and you delete the links and the old IDs, and you have your database that is ready to work just by replacing the name of your IDs in your code by the name of the GUID instead, and and all these steps are really there in the how-to, because I had to go through them several times. I can assure you that every step is there. Didn't want to lose anything.
Okay, another one who has a question?
I have a question about those blobs you spoke about. What if you have a database with 100,000 or 1 million records? Will that uphold?
Oh, sure. No, I've managed that without any problem. The only thing that you have to know is that when you're doing an initial database enrollment, you need to send all the records that are needed. So if you're doing a replication between servers and you need everything, and you need to send 1 million records with blob in them, it's basically possibly hundreds of megabytes, terabytes of data. So that will take time. There's no question about it. If you need to do that faster, it is possible. That's not something that I have implemented in that system, but I had implemented in the first replication that I had. If you want to increase the speed of the enrollment with big databases, it's possible to create a system that is going to create a basic enrollment package with everything in it. So you do the process once, the long process once, with the correct pointers. When somebody enrolls, you send that big file first, that's a big download, and woof, you have all your files local. and then you replicate what was changed since that point. It's possible to improve the process at that level if you have a big system and you cannot wait when you add a new system. Now, if you don't care, you add a new server, and if it has to run for 14 hours doing replication to send everything, you don't care about that. The existing system works perfectly well. But yes, it will work with any size database. I've had databases with terabytes of blobs. That's not a problem.
Okay. Yeah.
Now, what I do in my application is that big files of block like that are separate. I don't put that in my main record. My main record has an ID. I put the same ID in the blob with in the file in the X, and I have a blob record or multiple blob record linked to that. That allows me to, without asking myself what I have to do each time I'm working with my main record, it goes fast. And when I need the blob, I go read them. There is a way to do that with the blob inside the main record. You can tell the W language to ignore the blobs, but that's one more step to do each time you're accessing the file. And that's something that any developer can forget at any point, and suddenly you have a process that goes very slow. So I'm working on the main record. I need a blob, go read it, display it, done.
Okay. Who else?
Yes, Fabrice, I have a question. More and more we are going into the cloud, Azure and Amazon, AWS. Is there anything different going to be on the replication side, or will it?
If you can run a Windev program and run on a Hyperfile database or any database, in fact, don't care about the database. If you can run a Windev program or WebDev program, it will work. Mm-hmm. We don't care where it is. There's nothing that works on the physical machine. Doesn't care about that. Just access. The whole system is based on the database itself, and one file in the database is all you need to do replication. So I don't see why there would be any problem with any system when you can run W language code.
Okay, and do you have any experience with the PC soft cloud?
No, I haven't used it. I've looked at the prices and I started crying, so I didn't go there.
Okay.
It's when I have a dedicated server that I use for a lot of testing and a lot of things, and it cost me a little more than 100 euros per month, and I have 32 gigabytes of RAM, 1 terabyte of hard drive, 16 or 32 hearts processor. So it's to have the same thing in AWS or PCSoft, it's 3 or 4 times the price minimum.
Yes. Okay.
24/7. I'm saying if you're having just a few hours, that's something else. But 24/7, all these solutions are extremely expensive.
Yeah.
That's what I've seen when I was able to understand the pricing grid, because I have to say that I was not completely certain that I made the right calculation. But from what I've seen, it is much more expensive than having just a dedicated server. So it's not something that I've used a lot.
Okay. Thank you.
Okay. If nobody has any questions anymore.
Well, either I was completely not understandable, or I was really, really good. It's
Yes, it was very good.
Fabrice. Very clear.
Thank you very much for your explanation, and we are impressed by your knowledge. And we hope that we can, maybe we can use it sometime. And
Yeah.
I don't know. I'm impressed by what you told us. Thank you very much.
Oh, you're
Yeah.
welcome.
Yeah.
Okay.
No, I think all of us. And your hour of explanation, yeah, went into the 2 hours almost. But it's complex stuff, of course, and yeah, but very grateful and very clear. But we have to look to the 8 hours on YouTube for the whole thing, maybe.
Yeah, because in that, on top of everything I said, that there you have all the information about the content of each project, what Windows does, what all this kind of thing. I didn't talk here, by example, there is a whole automatic generation of record system available in it. So you can test with fake data without any problem. You have lots of things that I just didn't have the time to talk about here, and that will give you a good starting point. All this course come from a presentation I did at WX DevCon in the States. It was a conference that happened at the time. It doesn't happen anymore, as far as I know. So it was 2 days on the replication with hands-on work after that. So lots of information that you will need. Take the time to go through it.
Okay. Well, with your permission, Fabrice, I will put this and Hype, of course, I will put this recording on my LinkedIn account with my several connections, of course. So maybe we can get you a new job, a new project, of course.
Hallelujah.
And yeah, and that's, of course, we are grateful. I am.
Anything
I have one furthermore question. Are you considering migrating this to a business model or in the future or not?
I'm not sure I understand the question.
Will this evolve to become a commercial product in the future?
Well, the WX replication system has always been open in that you can do whatever you want with it. It is not a product per se, in my mind. It is a tool that you have to include inside your own project. Now, what I did with after that was the WX EDM, the electronic document management that is replicated. That could become a commercial project. It's possible because it's a full project. It is an example of what you can do with the replication for electronic document management. So that could potentially become something, but I have to tell you, I'm quite good at the technical stuff. For the commercial stuff, not so much. I would need somebody else to do that part because I'm not very good because I don't really like that part. So I prefer to say all this at this point. I have no objective to transform that or to make commercial version out of it. Maybe it will happen. Maybe somebody else will do it. It's perfectly possible. But if that happens, it won't be me alone. That's nearly sure. And in any case, the open source will stay open. That's it's out there for everybody to use.
Okay.
Okay, thank you.
Thank you very much. I take a
toast.
Toast to Fabrice. We are grateful that you were here, and hopefully we will see you somewhere, sometimes, anywhere. Okay. Thank you. And I
keep in
go
touch
to
with you, Fabrice.
Sorry.
What?
I'll keep in touch with you, Fabrice. Maybe on the commercial side of it.
Okay.
But
No
I'll get
problem.
back on you. To you. Yeah.
No problem.
I stopped.
You will know where to find me.
Yeah,
Yes.
I know.
And we stop this meeting now, this Zoom meeting. Thank you very much. Goodbye.
Thank you.
Never
Goodbye,
be tired.
Bye,
everybody.
everybody. Tot ziens.
Keep safe.
Thank you, Fabrice.
Uh,
Thank you.
Hi.
Thank you. Bye.